Okay, this is the way I did this question from the FP exam, okay? So we've got the parabola with this equation, y squared equals 16x. We've got 2 points, and we know that P and Q are not the same as each other. It says the tangent to C and the tangent to C at Q, meet at this particular point here. So we're going to try and find the area of these things. Now, I like to start off with a sketch to figure out what this is going to be like. So we've got something that looks like this. We've got a tangent at one point, a tangent at another point. So this is P, this is Q. They meet at a particular point R. We're then eventually going to try and show that the area of this triangle PQR is 1, 3, 3, 1. Okay, this is not an easy question, but we're just going to break it down into making sure we get all of the marks that are easy to get. So we start off with the equation of the parabola, and clearly we're talking about tangents. So we need to come up with the equation of the tangent. Now, if y squared equals 16x, do you do implicit differentiation or do you do parametric? Which do you prefer?
Parametric.
I think I do parametric, probably. So if I just have a look at this one for p, I can see that x is equal to p squared. So dx dp is 2p. If y is equal to 4p, then dy dp is 4. So dy dx is 4 over 2p, which is 2 over p. So the gradient is 2 over p. So you can do implicit as well, and you'll still come up with the same gradient as 2 over p. Someone decided to change it from 2 over p to 1 over p midway through the question. Who was that?
Not me. No.
Ruhan. Yeah, Ruhan just suddenly changed it from 2 over p to 1 over p. So you get y minus y1, which is 4p, equals m brackets x minus p squared. So then we should probably multiply everything by p to get rid of this. So I get py minus 4p squared equals 2x minus 2p squared.
So py is 2x plus 2p squared, to simplify it.
Yeah, so we could simplify that. But what I'm going to just do before that, this one is my equation of the tangent at p. My equation of the tangent at q is going to be the same thing. It's just going to be qy. Qy minus 4q squared equals 2x minus 2q squared. And we know that these two things intersect each other when it passes through the point minus 28, 6. So both of them go through the point minus 28, 6. That must mean for this thing here, when x is minus 28, y is 6. So I get, why am I crouching down? I should just move the board up. So we're going to now have y is 6. So you get 6p minus 4p squared equals minus 56 minus 2p squared. You get a quadratic, add the 4p squared, so you get 2p squared minus 6p minus 56.
Divide by 2.
Could divide by 2, or you've got an equation solver in your calculator, and immediately it gives you the value that p is equal to 7 or minus 4. Now, it's the same thing for this one as well, because it's exactly the same equation. So you also get that q is equal to 7 or minus 4. Now, I'm not bothered which one is which, okay, because it's just saying there are two places where this tangent will work. So if we know that p is 7 or p is minus 4, our coordinate of p, is it p squared 4p? So then our coordinate of p, if we say that p is 7, will be 49, 28. This is if p is 7. Our coordinate of q is q squared 4q. So q would be 16 and minus 16. So now we've got a completely different problem that is almost like a part 2 of this question that we've got here. We've now just got 3 coordinates. We've got P, and I don't care if these are drawn correctly or not. I've got P, Q, and R. Then probably not drawn correctly at all. And we're trying to find out the area of this triangle. So we've just said P is 49, 28. Q is 16 minus 16. And R is minus 28, 6. Now, there's many ways that you can find the area of this triangle. You could do this from normal maths, where you could find out the vectors for the sides of the lengths, or you could do this using a further pure 1 skill. I'm probably going to do a further pure 1 skill here just for fun, okay? So I'm going to work out two sides of the triangle as vectors. I don't really mind which two sides to do. I might do QP and QR. So you'll find out what QP is by doing this one minus this one. 49 minus 16 is 33. 28 minus 16 is 44. QR will be R minus Q. So you get minus 28 minus 16 is how much? Minus 44. And then 6 minus 16, which is 22. Okay? Now we're trying to find out the area of this triangle. Do you remember that to find out the area of a triangle, it's a half times the modulus of the two things crossed together. So it's going to be a half times QR crossed with QP. So let's actually just work out what is QR crossed with QP. Now, you get your I, J, K. Well, the I for QR is minus 44. The J is 22. The K is 0. There has to be a... Why does there have to be K when you do the cross product? Because the cross product has to be in 3 dimensions, because it's finding a vector which is perpendicular to 2 other vectors, which means it has to go into 3 dimensions. And then you've got your other bit, which is QP, which is 33, 44, 0. Do the cross product, which you could put in your calculator if you wanted to do the cross product of this vector and this vector. Take them... Yeah, there's a way of doing cross products in a calculator.
Is that what, as a matrix?
Yeah, although somebody might have said that you can't do that in exam mode.
You can do anything.
So it's not as matrix, it would be vector product. So if you go to menu...
No, vector functions don't work in exam.
Vector functions don't work? You sure?
Yep,
Okay.
on the notes.
It will be 0, 0.
So you get the I part will be 0, 0. The J part, which will be a minus, will be 0, 0. And then the K part is minus 44 times 44 minus 33 times 22, which is minus 2662. But the area then would be a half times the modulus of this, which is 1331. Okay, you don't know that you can use this, but in FP, it's often going to be like something they want you to use. And I think they get you to try and use this again in the next question. It's just madness, the amount of stuff that they try and get you to use. So let's just quickly talk through what we did there. It sounded like quite an overwhelming question, but all it's talking about is tangents. So you better make sure you know how to find the equation of the tangent. Then they tell you that the tangent goes through that point. Well, there's no point in trying to do, and I think Ibrahim tried to do this, I think there's no point in trying to solve this and this simultaneously to come up with this. You just know that that one passes through that, that one passes through that. They're exactly the same equations as each other. So just do it with one, generates the 2 points, tells you P and Q. Once you know P, Q and R, you can do all of that to find out the area. The unfortunate thing with this question is actually this bit down here. Do you know how many marks this is worth?
5.
2.
Oh.
2 marks, okay?
Nice.
So there's a lot of time. You get 1 mark for doing the method, you get the 2nd mark for it being correct.
What if I got the actual equations? Would I get like 3 marks or 4?
You probably should. It depended on what it said in the mark scheme.
Right.
I can't remember off the top of my head how many it is.
That's why it's not.
So which other one would you like? Should we do the other Conics one for FP?
Sure.
Do you want to do the Conics one or do you want to do the vector one?
No, the vector one was fine as made a mistake.
Okay, well we'll do the hyperbola one now. Let me just grab the question.
Oh, I drew that.
I've been asking for
I'm thinking I was kidding.
I'll ask him
Where's
for
your
that.
guy?
How much did you go? You're 18?
Yeah.
Oh gosh, here we go. Okay,
I got 6 marks for doing that.
so again, we're being asked to find the tangent to this point here. So let's just find the tangent to this point here before I even do anything else. I'm just going to find the tangent to that particular point. Then I'm going to come back to the question. I've got to find the equation of the tangent. So I'm going to do some working out for that up there. We know that, can we go straight to what dy by dx is equal to if we differentiate this and divide it by this differentiated?
Implicit, yeah.
Well, we could do implicit, but we could just go parametric, couldn't we?
3 cos 3
So that's going to go to 3 cosh and that's going to go to 4 shine. So we get 3 cosh theta over 4 shine theta. And so your equation of the tangent will be y minus y1, which is 3 shine, equals m brackets x minus x1.
Oh, excellent.
And probably it's going to be a good idea to multiply up by 4 shine theta here. So I get 4y shine theta minus 12 shine squared theta equals 3x cosh theta minus 12 cosh squared theta.
You can use the finger rule.
There's an identity that's in here.
12 sine squared theta minus 12 cos squared theta, you get 12.
Yeah, it's the other way around. So it should be, it's 12, the cosh take away shine because of Osborne's rule. So if I were to put the 12 cosh onto that side, I would get 12 cosh squared theta minus 12 shine squared theta, which is equal to 12. So I now get 4y shine theta plus 12 equals 3x cosh theta. That's my equation of one of the tangents that's going to be very useful. And I'm going to just label this here. I'm just going to say that is L1. I'm not sure how many marks that was worth, actually.
4. I got 4 marks. So
4 marks just for doing that bit.
1, 2, 3, 4, 5.
Then we've
5
got,
marks for doing that.
he might have had something missing. Or you might have had
Yeah,
you might have had
I got
L2 as well. I don't think he's got
my
L2.
12 was another side by.
LT was 6.
So we've now got that the line L1 meets the x-axis at the point A. Let's deal with this next sentence. When it meets the x-axis, what do you know?
Y equals 0.
Y equals 0. So I'm actually just going to go straight in here and say y equals 0. This thing is equal to 0. So you just get 12 equals 3x cosh theta. Divide both sides by 3 cosh theta, and you get 4 over cosh theta is equal to x. So that must mean that your coordinate for A is 4 over cosh theta, 0. Do you see how we're just working through the question line by line?
Yeah.
And I'm going to put a box around that because I think that's now going to become more useful. Okay, we've dealt with this bit. We've dealt with this bit. And it now says the line L2 is tangent to H at the point 4, 0. Now you don't need to go back up here and substitute in values. You just need to do a sketch of the hyperbola. So the sketch of the hyperbola is like this. What are the points where it crosses the x-axis?
Minus A over E.
No, that's the foci.
AE.
What are the look at this and see if you can tell me what the coordinates of this and this are.
4.
Yeah, because this is your a squared. So this is 4. This is minus 4. So the tangent to the hyperbola at 4, 0 is this. The tangent has to be that line that we've got there. So L2 is just x equals 4.
That's why I wrote 4.
That's why you got an extra mark, because you said that x is
No,
equal to
that's
4.
not 6 mark.
That's your 6 mark, okay. So we've now come up with the line equation of L1 and the equation of L2.
But then that's easy, just sub in 4 to the...
Exactly. It now says the lines L1 and L2 meet at the point B. So we're going to now find out where this and this meet each other. So I'm going to substitute 4 into here. We're now going to do a substitution to find B. So let's do 4y sine theta plus 12 equals 3 times 4, which is 12 cosh theta. We need to try and find out what y is equal to. So what can we divide everything by first? 4, so we get y sine theta plus 3 equals 3 cosh theta. So we get y equals 3 cosh theta minus 3. over sine theta. So that must mean that the coordinate of B is the x coordinate is 4 and the y coordinate is 3 cos theta minus 1. I've just factorised the top over sine theta. Yeah?
Yeah.
Everyone with me?
Put that in a box.
Put that in a box, that's going to be important. So now I've got coordinates of A and coordinates of B. Look how we're working through the question. We've dealt with this sentence, we've now got to deal with the second part of the sentence. The midpoint of AB is M. So now I'm going to look at this thing and this thing to try and find out what the midpoint is.
I'm an idiot.
What do you do for the midpoint?
Divide by 2.
Add and divide it by 2. So it's going to be a half of 4 plus 4 over cos theta, and then a half of this thing, which is 3 cos theta minus 1 over sine theta. So now you've got the midpoint.
So we're missing a bracket.
Where?
Half divided by 2.
Thank you. Now we've got A, we've got B. What should I do? I'm going to put a box around it because this is going to be now useful. All the other things that have got boxes
So that's
in.
A, that's B, that's M.
Now nothing else is important. The only thing that's important to me now is M.
Yeah, because you want the locus of M.
Now we are going to try and actually get to the question which says shows theta varies. A Cartesian equation for the locus of M is this thing with some restrictions on x. This is really, really heavy. You know, in the question we did in the pure exam where we did the mice question where it was like differentiating n and you had to show that it was n brackets n minus 3. It's like that kind of thing, okay? This is only worth, at this stage, I think this is only worth 2 marks. Possibly 2 marks, I think. It's not worth many. Because so far, I think we're probably about 8 marks. So
it'll be 3 marks.
no, because there's 1 mark for doing this as well. For P and Q's stuff, okay? So to do the locus, we've now got that x, and I do capital X to show that it's not the same as the previous one. We've got that x is equal to a half of this, which is 2 plus 2 over cos theta. And we've got that y is equal to a half of this, which is 3 cos theta minus 1 over 2 sine theta. And the thing we're aiming to do, is y squared equals 9 4 minus x over 4x.
No, we're not subbing the middle.
Don't say something.
No.
I'm going to be so annoyed if you say something.
No.
So you're going to take the y value and we're going to square it,
Yeah.
and then we're
For
going to
God's sake, Riyadh.
and then we're going to do the same on the right hand side, and we're going to show that they're equal to each other.
So hard.
So y squared is equal to, you get 9 cos theta minus 1 squared over 4 sine squared theta. But I think it's not going to be very easy to spot if it's y squared.
You're simplifying.
What do you think I should do to the numerator?
The rule, what's that rule again?
So when you expand, what's cos theta minus 1 squared?
Cos squared theta minus 2 cos theta plus 1.
Oh, actually, I don't think this is a good idea because I know what's going to happen next, because that doesn't seem to be doing anything interesting, does it? I'm going to leave that.
You show me the next side.
I'm going to just do the other side, and then if I can't make it look like that, we'll see what happens. So I'm not going to sub it in straight away. I'm going to sub it in really, really slowly until I make it look how I want it to look. So first of all, I'm going to work out what 4 minus x is. So 4 minus x is going to be 4 minus 2 over cos theta. So that just becomes 2 minus 2 over cos theta.
Times that by 9.
Then I'm going to times that by 9. But before I do that, do you think there's anything that you should work out here?
X is sine squared f theta.
I think probably my instinct would be to do something to this that I've got here. Yeah, I guess factorize the 2 out. I guess what I'm looking at with y squared is a single term. So I think I don't want these as 2 separate terms because I'll never make it look like something that's a single term. So I get 2 cos theta minus 2, which is the same as factorising it, over cos theta.
Okay.
And now if I'm going to multiply it by 9, I'm going to change that to an 18. You with me?
Yeah.
Yeah.
And then divided by 4.
Now I'm going to divide it by 4x. So I'm going to go back to the beginning bit and work out what 4x is before I actually do the division. 4x would be 8 plus 8 over cos theta. Now if we keep going with this, we should do the same thing again and we should combine it. So we get 8 times cos theta plus 1 all over cos theta. So that's what 4x is.
Oh, the cushions go away.
Now the thing we're interested in is doing, what are we aiming for?
9.
That one divided by that one. So we want to do this one divided by this one. So we get 18 cos theta minus 1 over cos theta times by
Over.
cos theta over 8 cos theta
Plus 1.
plus 1.
The coshes cancel out.
The coshes cancel,
8 will cancel with 8 to make 9 and 4.
so you get a 4 there and a 9 there. This whole thing is equal to the 9, 4 minus x over 4x. So let's just simplify what we've got. We've got 9
Oh my days.
cos theta minus 1 over 4 cos theta plus 1 is equal to 9, 4 minus x over 4x. But that doesn't look like this thing. I need them to match.
Change the bottom bit to.
Well, no, but the top bit
No, you
is
just-
has it squared.
Times it by cos theta minus 1 over cos theta minus 1.
Yeah.
And then
Yeah.
you get cos squared theta minus 1 at the bottom, 4 lots of it.
Good, so you want to
And then you
manipulate
get
this
shine.
one. Okay, so if we manipulate this one rather than that one, I manipulated that one when I did it, but if we manipulate this one, we will multiply the top and bottom by, what did you
Cos
say?
theta minus 1.
Cos theta minus 1, because that's all we need to do to get it to look like the one on the top. So on the top part, you get 9 cos theta minus 1 squared, and on the bottom part you get 4, and you've got a difference of 2 squares
Cos
here,
squared theta minus 1.
which is cos squared theta minus
Is
1,
equal to shine squared.
which is equal to sine squared theta. So you get 9 cos theta minus 1 squared over 4 sine squared theta. So you get y squared equals 9, 4 minus x over 4x.
And then you've got the balance between the...
We still haven't finished.
Whoa! That's 10 marks. That's the 10 marks.
That's 10 marks, we still need to work
And
out.
then we haven't done part B.
My
We
page
still
is
haven't
finished,
done
man. My page is done.
What P and Q are, okay?
The balance.
Because it says where P and Q are values to be determined. So,
Cos and sine, like...
So that's
they have
2.
limits then.
So now we
yeah,
need
you
to-
know what the graphs
now we
are.
need to sketch
So,
that graph sort of, don't we?
the things that we've got for the domain of x, now,
Can we just draw the graph and see what
no, you've got to think about the x values that you've got here, okay? What do you know about cosh? What values can you have for cosh? What does the graph look like for cosh?
Is that one?
No, cosh looks like this.
Oh, it's inverse is the other one.
Yeah.
It's that one.
And
So,
that's 1, isn't it?
so the smallest thing that cosh can be
It's one.
is 1. So if we just come back and if we're going to investigate now the domain, and we know that x is equal to 2 plus 2 over cosh theta, we know that cosh theta is always greater than or equal to 1. So if cosh theta is equal to 1, you get that x is equal to,
2 plus 2, 4.
good. And now if cosh theta goes to a really big value,
Just 2.
you just get 2. You get that x is 2, which tells me
Oh,
that the values that x can be are between 2 and 4. So p is 2 and q is 4.
Let's do it. Yeah.
That's why it's 1 mark.
That's why it's 1 mark for that last bit.
You've
Then,
done that right at the start, like before we even did this manipulation.
Yeah.
right?
yeah,
Okay.
This is so crazy.
that's all 11 marks. Like, it's kind of unbelievable.
No, but it's worth, isn't it? Like, everything makes sense.
It makes sense. But
Yeah,
it's
you
one
try
thing-
doing that in
it's
an
one thing-
80 mark FP1 paper and
Exactly,
then
yeah.
tell me it makes sense.
it
And
makes
now-
sense- the thing is, it makes sense now. But
Part B, there's still more. Oh my god.
yeah, part B. Let
Right.
S be the
It
focus.
says, let S be the focus. To find out the focus,
A over something.
Yeah, I need to get my formula book because I can't remember what it is. For a hyperbola,
Oh my god, the formula has it, doesn't it?
Yeah, I know.
Oh, yeah, that's all the same.
You didn't even need to do part A to do part B. No, because it's already given to you, and then
so for a hyperbola, the focus is AE naught. And we also know for a hyperbola that b squared equals a squared e squared minus 1. What is the value of a squared for our hyperbola that we've got?
16.
16, and b squared is 9. So a squared is 16, b squared is 9. So using this, we get 9 equals 16 e squared minus 1. So you get 9 over 16 plus 1 equals e squared. That works out as e being 5 over 3.
Yeah.
5 and 4, isn't it?
5 over 4. Yeah, 25 over 16, sorry. So this is why you shouldn't try and do things quick. So e is equal to 5 over 4. So the focus, S, what's the coordinates of?
5,0.
It's just 5, 0.
Because it's
Now the
84, right? Yeah.
question says, let S be the focus of H that lies on the positive axis. Show that the distance of M to S is greater than 1. So
Where's M?
M
Is
is
that
the midpoint.
Oh my god.
Now, you have to think about what the midpoint is going to be. How did I do this before?
2 plus 2 cos theta.
Okay, if we come back to this diagram, this is one of the lines. This is the focus S, which is at 5, 0.
Yep.
Now, the two things we talked about here was that there is a tangent at this point that stays fixed, and there is another tangent. If you think about the fact that this tangent is always going to be at 4, and this one is at 5,
The shortest distance is always going to be 1.
the shortest distance that the midpoint is ever going to be able to be is 1, because
Once it tends away from it.
once it goes away from it, it's going to get bigger. So you need some sort of explanation that says because focus is at 5 naught and L2 equals 4, the minimum distance of M is 1.
That's it.
And that's it. I mean, it's a pretty savage kind of question, right?
No, so